Good morning everyone. Last class we had discussed how to record the simple muscle curve. So today's experiment will be to demonstrate the effect of temperature on a simple muscle curve. Now this experiment works on the principle that when a muscle is warm with a warm temperature, the various phases of muscular contraction hasten and cooling has a reverse effect. Now this experiment is recorded in the same way as recording the simple muscle curve, only with the exception that we will also use Ringer solution in two other temperatures. So here in this experiment, like the simple muscle curve, once we will use the normal Ringer solution. Next we will use Ringer solution at a temperature of 36 degrees Celsius to 40 degrees Celsius. And we will also use cold Ringer solution at a temperature between 5 to 10 degrees Celsius. Now how is this experiment done, or how we will demonstrate the effect of temperature? Now you see, just like the simple muscle curve, the connection is similar. We have the primary circuit being made, and we will first put the simple muscle, the nerves, the gastrocnemius nerve muscle preparation in the myograph board. And at first, before we start, what we will do is we will take a simple muscle recording. Okay, now first we will take a simple muscle recording. Once the drum goes, we will take a simple muscle. We will stop the drum. Then what we will do, we will pour warm Ringer solution over this muscle, the nerve muscle preparation. Now once we pour the warm Ringer solution, we will wait for 5 to 10 minutes, and we will, with the thermometer, we will check whether it has achieved the temperature of the Ringer solution, of the warm Ringer solution. So once the temperature is achieved, we will keep the point of stimulus same. Again we will bring back the point of stimulus same, and we will record a second curve. Okay. Now after recording a second curve, we will again wash this preparation with normal Ringers, and with the thermometer we will check whether it has come back to room temperature. Once it has come back to room temperature, now we will pour over it cold Ringer solution, that is at a temperature of 5 to 10 degrees Celsius. We will wait for 5 minutes and check whether it has been achieved or not, and once the cold temperature has been achieved by the nerve muscle preparation, we will take again a recording. So when we will take a recording, the recording in the board will look like, you see, first we have recorded the simple muscle curve. So you know that there is a point of stimulus, then you know there is a latent period from, and then there is the muscle contraction. So this you already know. So this is the simple muscle curve. We will label it as N. That means a curve that was recorded as the normal temperature. Okay, so this is the C, that is the point of contraction. Then I told you we will wait for 5 minutes and we will pour warm Ringer solution, and we will record again. We will record the recording of a simple muscle curve, keeping the point of stimulus same. So once the point of stimulus same, we will again record a simple muscle curve, and we will get a second simple muscle curve. And we label it as H. That means when we have given hot Ringer solution. Okay. Then we will again wait for 5 minutes, allow it to come back to normal position. Then I told you we will pour cold Ringer solution. So once we will pour cold Ringer solution, and that has been achieved by the nerve muscle preparation, next we will again take a recording. Okay, so we will take a recording. Okay, so this we will label as C, that means cold, and we will take the time tracing as we have taken in the simple muscle curve. Okay, the similar fashion. Now you see here, This is the point of where I have written pH, that means that is the point of contraction of the one with when we have given warm rigor solution, and the point where I have written your PB, this is the point where we have given the cold rigor solution. Now from this curve, what are the things that we note, or what we will note in this experiment is, first let's see about the latent period. The latent period, you see, the first latent period, that is for the normal. If you see here, the gap is between the PS and PC, so this is the latent period of the normal. Okay. Now you see for the latent period for the warm rigor solution, you see this where I have written LPH, that means latent period of the hot rigors, and you see this for the cold solution, this from the PS to the PB, so this is the LPC. Okay. So here if you follow the space or the diagram, you will find that LPH is less than LPN, which is again less than LPC. That means as we increase the temperature of the nerve muscle preparation, we find that the latent period will decrease. It is decreasing, and as the temperature becomes less and less, that means with the cold temperature we find the latent period is increased. So increase in temperature causes a decrease in latent period, and a decrease in temperature causes a increase in latent period. Now why increase in your temperature causes a decrease in latent period? Okay. Now first of all, you have already known from your theory that when temperature increases, the nerve conduction increases. So one of the causes for latent period was why we get latent period is the time taken to transverse the nerve, the time taken by the impulse to transverse the nerve. So if temperature increases, that time decreases. So if it decreases, that means the latent period will decrease. So the first point for the decrease in the latent period with increased temperature is faster nerve conduction. Okay. Now next, with increased temperature, what will happen? The inertia of the muscle will also, the inertia of the liver and the muscle will also be overcome at a faster rate. Okay. And moreover, the conduction through the neuromuscular junction also increases during your rise in temperature. Now because of all these three factors, we find a decrease in the latent period with the increase in the temperature. Okay. Next we come to the other phases of contraction. Now before coming to the other phases of contraction, if you see, we'll draw the height maximum in both all the curves. You will find for the contraction phase of the normal curve, if I label it as this one, this is A, suppose this is A. Okay. Now if you see the contraction phase of your this worm, this is suppose B, and if you see for the contraction phase for the cold solution, we find it as C. So here also we find that as the temperature is increasing, the contraction phase is shortening. There is shortening of the contraction phase. Now why is there shortening of the contraction phase? As well as if you see the relaxation phase, they are also shortening. So we find that the various phases shorten with rise in temperature and they will prolong with the fall in temperature. Now why there is increased rise? Okay, why there is an increase in the rise? Now this increase in the rise is because as we increase the temperature, the increased temperature causes an activation of myosin ATPase activity, the enzyme myosin ATPase, which is required for muscle contraction, that is increased. So once that is increased, once the activity increase, the contraction will obviously be increased. And moreover, what happens, the viscosity of the muscle is also overcome easily. So if the viscosity is overcome easily, as a result, what will happen? The muscle contraction will become faster. Now you see the height. Now look at the amplitude of the contraction. The height will represent the amplitude. We find that the one where we have given warm ringer solution, the height is maximum, then is the normal one, and last is that of the cold ringer solution. Now why is there increase in the amplitude? It is found that whenever there is an increase in the temperature, the enzymatic and the metabolic activity of the muscle increases. Moreover, whenever there is increase in the temperature, the calcium ion which is present in the sarcoplasmic tubules, they are released at a faster rate and they are released more. So because of more increased amount of intracellular calcium, the force of contraction also increases. Therefore, we get an increased height in the amplitude of the contraction with the warm ringer solution. Now here you see, so from this experiment we have come to know that whenever you rise the temperature, the latent period, the contraction phase, as well as the relaxation phase all become shorter, and with the decrease in temperature, you find both all the latent period, the contraction phase as well as the relaxation phase, all of them will elongate. Now here there is a question, or one thing you have to remember is that when I have told you also, I told you that you have to pour hot ringer solution before pouring cold ringer. So when I told you about the experiment, I told you first you pour the warm ringer solution. Why is it so? Now that is because when you pour cold ringer solution, okay, now this cold causes an inactivation of the enzymatic and the metabolic activity. It causes the inactivation of both the enzymatic as well as the metabolic activity of the muscle. Now once it is there, the enzymes become inactive. Since the nerve muscle preparation is outside the body, so what happens, it becomes more or less near to impossible to revive that muscle from that inactivity. Okay, and this inactivity that is caused by cold is known as cold rigor. Now though if it is inside the body, cold rigor is always a reversible process. Okay, but here since we are doing it in the experimental process, you have to always give the warm ringers before cold ringers. So once you give cold ringers, it may be the muscle may become inactive and then you may not be able to record the warm ringers result. Okay. Now here one thing, in the hot ringers, for the warm ringers, I told you the temperature should be between 36 to 40 degrees Celsius. Now why this range of temperature? Okay. Now you just see that if you give temperature above 40 degree, what will happen? The muscle proteins, the muscle is made up of proteins, well, as you all know, there will be denaturation of these proteins or breakdown of these muscle proteins. Now once there is coagulation and denaturation of the proteins, what will happen? The muscle will shorten and it will stiffen, and once the muscle stiffens and it shortens, we cannot record its contraction. Now these shortening and stiffening of muscle which occurs because of coagulation of proteins and because of heat is known as heat rigor. And you have to remember that heat rigor is an irreversible process, because of which we never give the temperature above 40 degrees Celsius. So these 2 points has always to be remembered in this experiment. First, that you never give cold ringers before giving the hot ringers, and second, when you give the hot ringers, it should not be above 40 degrees Celsius. So from this whole experiment, we come to know that the effect of temperature on the simple muscle curve is that increase in temperature increases the amplitude of contraction but decreases the latent period and the contraction phase and the relaxation phase, and the cold temperature causes a decrease in the amplitude of contraction with an increase in the latent period, the contraction phase and the relaxation phase. Now the curve that is shown to you, that will be shown to you, is this curve. Okay. So here if you can see the curve, you see where it is written N, that is the normal curve. Where it is written H, that is the one which is recorded with your warm ringer solution, and the one where it is written C, this is the one which is recorded with your cold ringer solution. So if you see the curve, you will find that the hot ringer solution, the amplitude is maximum, and the cold ringer, the amplitude is minimum. If you see the latent periods, you will find that the hot ringer, the latent period is been decreased, then the normal, and the normal's latent period is more or less, as compared to the cold ringer's solution. Okay, so all the phases of contractions are also shortened in your hot ringer solution. So if this curve is given to you, you will say that this is a myogram showing the effect of temperature on the simple muscle curve.